Okay, so I've been asked to do a bit of a recap on surface area and volume. So I've picked a couple of questions for you, and we're going to have a look at how much icing is on this slice of cake. Now, this icing is on the top, around the curved back of it, but also there's two layers in between, and we're going to, I can see that that's icing as well, it's not cream. So let's have a look. What do we do for area of a circle? We say that area is pi r squared. Now let's have a look at this shape here on the top. It's not a full circle. It's a fraction of a circle. What fraction of the circle do we have there? Well, that's 30 out of a possible of 360. And we can simplify that, crossing the zeros off. 3 into 36 is 12, so that's 1/12. So we've got 1/12 of the circle. So that area just up the top there, that's going to be, so we're going to sort of draw it like this with 30 there, 30 degrees there, and a 6 centimetre radius. So that area is going to be by itself 1/12 of pi times the radius squared. So we could simplify that a little bit. That would be 36 is 6 squared. So that's 36 pi, which is still 1/12 of that. Now 12 goes into 36 3 times. So that's actually 3 pi, my area on that top there. Now there's the same amount in each of these levels here. So I've got 3 of them. So if I multiply that by 3, because there's 3 of these, my surface area just for that part of the icing is going to be 3 by 3 pi, which is 9 pi. Now let's put some units on, square centimetres. Okay, but what about that curved surface round the back there? We need to do that and add it on. Okay, so if I was going to look at that, that is a part of a curved surface of a cylinder. Now the curved surface of a cylinder, let's just remember what that is. That's actually the same as a rectangle, which has a height, and the length is the same as circumference of the circle, so that's 2 pi r. Okay, and that area in there, therefore, is 2 pi rh. So that's the curved surface formula of a cylinder. But remember, we don't want the whole cylinder, we've only really got a part of it. What fraction of it do we have? Well, we've got 1/12. So that side there is 1/12 of the whole curved surface of that cake before it was cut. So that part there is going to be 1/12 of 2 pi times the radius times the height. And we can simplify that. So 6 4 is 24. I need to divide that by 12 and times by 2. So that's 4 pi. Just check the arithmetic if you're not sure. 2 times 6 times 4 divided by 12 should be 4. And the pi remains in there because I'm doing it exact at the moment. So that is what comes from our curved surface. So all up, what have we got? So our total comes from this answer here and this answer here. So our total is 4 pi plus 9 pi, which is 13 pi, and let's put our units on square centimetres. All right, The main thing to realise when you're doing these surface areas is to have a look at each face and do it a bit at a time. So see that one there? That's the top. But it's also there and there. And then this bit here, because we only want 1/12, let's pretend that's a 1/12 part of it. It's not really good, is it? That's around the side here. Okay, so that's how we've done that one. Let's move on to another one. Now let's do volume. So I've picked out a canvas tent, and to do volume, we've got to remember that volume is A times H. But it's not just any A. What is this area A that I'm talking about? It has to be the area that is constant as a cross-section from one side through to the other. Now, if you have a look at my picture here, see this shape at the front here, colouring it yellow. Now, that's the same at the front and also at the back. Like, if you could imagine going to the back of that tent, you would see the same shape at the back. All right? That's kind of looking through it as if you could see through, but you can't see through it, all right? So we know that that is at the back. So that's a constant cross-section because it's the same travelling from the front to the back. So that's this area here that I need, the constant cross-sectional area, and that's what I've drawn here. So the first thing we need to do is figure out that area. So that area is made up of this rectangle here. See this rectangle here? And let's write this down. That is a 1.6 by 2 meter rectangle. All right? But then I have to add the triangle on the top. So see this triangle on the top there? That's a base of 2 times a height of 1 over 2. That's how we do area of a triangle. So let's put that together for our area. So 1.6 times 2, that's 3.2, plus 2 times 1 over 2, that's just 1. So I'm getting an area there of 4.2. Okay, so that's what that area is. Great, that's that bit there. So we've done that. But we need to multiply it by this height here. See that height there? So the height is how far that shape travels from one side to the other. Well, guess what? On the diagram, there it is right there. It's your, well, better not cross out that one. It's your 4 meters. So let's go back and do our volume. Volume equals A times H, which is going to be 4.2 times 4. 4 2's 8, 4 4's 16. So it looks like it's 16.8 cubic meters for our volume. So that's a little recap of volume and surface area. Hope that helps.